Hi, this is the third section in the first unit. We're still in univariate data, and we are going to talk about sigma notation and measures of center. So first we're going to tackle sigma notation, and it's going to become obvious as to why as soon as we define measures of center. So first let's look at this symbol right here, where we have this sigma right here, which stands for summation or addition. We've got this I equals 1. That's going to tell us our starting integer. So starting integer. And what that means is it means anywhere in this expression that you have right here, anywhere you see an I, you're going to start by plugging in 1 for it, substituting in 1. Next, after that, you're going to add the next term. And when you add that next term, let's actually just go ahead and write this out as we do it. You're going to start by anywhere you see a I, subbing in a 1. Then you're going to add, because of the sigma notation, x, and instead of that 1, you're going to add the next integer, which is a 2. Then you're going to add, you're going to substitute the I with the next integer, the next consecutive integer, which is a 3. Then a 4. So you keep on going up to the next consecutive integer, subbing in for I, because that's what it tells you to do right here. Now the question is, how long do I keep this up? And the answer comes at the top of that sigma notation. So you can see where you've got an n up here. Whatever that n is, that's the integer you're going to stop at. Okay? So I know this is super theoretical right now. Let's try and put this in perspective. Let's do an example so that you can see this. Okay, let me make one up. So let's say I say, example, evaluate sigma from, let's not do an I, let's do a k. K equals 1 to 4 of 2k plus a 3. Okay, so let's take a look at what this means. This means I'm going to start by plugging in k equals 1. And I'm going to plug in every consecutive integer all the way up until 4. So some people might like to say, all right, let's set this up by knowing I'm going to plug in k equals 1, 2, 3, and 4. And let's start by just plugging in those values. So if I were to plug in k equals 1 to this expression right here, I'd have 2 times a 1 plus 3. That's going to give me a 5. Next, I'm going to plug in k equals 2 to the expression. So if I plug in 2, I get 2 times 2, which is 4, plus a 3. So that gives me a 7. Next, I plug in k equals 3. So 2 times 3 is 6, and 6 plus 3 is 9. And last, let's go ahead and plug in the 4 over here. So 2 times 4 is going to be 8, plus 3 is 11. And the reason I'm adding up all of these terms is because of this sigma notation right here. So when I add these up, 5 plus 7 plus 9 plus 11, I end up with a 32. So whenever I say evaluate k equals 1 to 4 of 2k plus 3, I end up with a 32. Not too bad, right? Let's take a look at another example that I've got down here. It says, consider the set of values. X sub 1 is 14, x sub 2 is 16, x sub 3 is 15, x sub 4 is 18, and x sub 5 is 17. Then evaluate sigma from I equals 1 to 5 of x sub I. So I first say, let's just take this very literally. This says start with I equals 1 and sub that in for I. Then I'm going to plug in the next consecutive integer for I. Then the next, then the next, and then I end up at x sub 5. And I know to stop at x sub 5 because 5 is the last consecutive integer that I'm plugging in. Now, if I didn't know what these values were, this is where I would stop, and I wouldn't be able to combine any of these because they're not like terms. But I can go ahead and substitute in all of these values because they've been given to me up here in the problem. So when I substitute all of those things in, I'm going to end up adding these up. And let's see, I know I'm going to have, that right there is going to be a 30. And then 45. These are going to be another 25 or 35 right there. So there'll be 80 when I add all of those up together. All right, last example that I have. Evaluate the sum from I equals 1 to 6 of I squared. So if you want, you can go ahead and make a little marker down at the bottom, just reminding you of all the values you're going to plug in. You're plugging in I equals 1 to I equals 6 to my expression. And now let's go ahead and do it. When I plug in 1 to my expression here, I just have 1 squared, which is 1. Now when I plug in 2, 2 squared is 4. Plug in 3, 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. Last step, I just add up all of these, and I'm going to end up getting a 91 when I add up all of those. So my final would say I equals 1 to 6 of I squared is 91. And I think we talked about this before, is I don't have to use an I. If I asked you to evaluate J equals 1 to 6 of J squared, that's also going to be equal to 91. All I did was I just changed the variable, and I can change it to anything I want. I could say, find the sum from m equals 1 to 6 of m squared. That's still going to be equal to 91. Just changing my variable. Alright, so now we're getting into the measure of center part, which is really why I needed to talk about all of this sigma notation. So it's convenient to use sigma notation when I define the mean. Now before we officially define a mean, let's talk about what it is, because I know you guys are really used to it. Mean is also called the average. It's probably what you're used to talking to it as. So let's take a look at this. It says, express the mean of the fastest 100-meter runs in sigma notation. So this is as of August 26, 2006, and these are the 10 fastest 100-meter runs. So here we can see these are the times that I'm looking at right here. This next row is comparisons, and then you can see the actual runners over here on the far right. So in order to find the average or the mean, I need to first find the sum of all the times. You guys can probably pull a calculator out so that you can do that on your own, but I've already calculated it for you. The sum is 96.91. That's the sum of all the times. And then to find the average, after I find the sum of all the times, I have to divide by the total number of runners. Don't get tricked here. There's not 9 runners. If I actually count these, I've got, notice I have these 3 people in 3rd place and all these ties going on. I really don't even understand what those mean, to be honest. When I calculate these, 3, 4, 5, 6, 7, 8, 9, I've got 10. And that's an easy division. So when I divide, I end up with 9.691 seconds. And this is my mean, or my average time for all of these runs. So now let's use that to define the mean. So it's worth noting that the mean is the most common measure of center. We're going to talk about 2 measures of center today. So first, we add up all of those data points that I'm talking about. You got to add them all up. So that would be the sigma notation, where I'm going to add up all of my data points that I've been given. And notice I have an n here because n just stands for the number of data points I have. My last step is I'm going to divide by the total number of data points. And so that is going to be the mean. I'm going to use x bar for the mean. So this is a symbol for the mean. This is what I'm using to sum all of my data points. And this is just the total number of data points. So let's look at this data set. I'm hoping you guys can see all of this. So it says the following data points represent the NBA players' average number of points scored per 48 minutes of play in the 2016-2017 regular season. So you can see we have all these basketball players listed here, and it's not, I don't believe these are on the same team. And we just want to find the average. So if I'm going to find the average number of average points, first I need to start by adding up all of these data points. And I've already calculated this, so it's 430.7 total points. So that's going to be the sum, 430.7. So the mean is the sum divided by the total number of players. So if I count up the players, I believe it's 18. I want to check behind myself though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. So I've got 18. So whenever I divide this out, I get 23.9278. So if I was going to round to the nearest hundredth, I would say 23.93 points per 48 minutes of play is the average for all of these basketball players in the 2016-2017 regular season. Take a look. It was 23.93. So the mean is going to be affected by outliers, and I think you all probably have heard this word before. So outliers are unusual data. It's the data that just doesn't feel like it actually fits. So what I want you guys to do is probably pause this video, and I want you to calculate the mean of these two data sets right here. So just pause the video and then come back. Alright, so if you've calculated the mean, you should have for this first data set a mean of 18.57. And for the second data set, you have a mean of 5. And the question is, which one better represents the actual data? Which one is a better measure of center? And I hope you're all saying that 5 is a better measure of center. You notice that these are the exact same data sets. Everything is the same. The only difference is I have an outlier here in the first data set. And what that is doing is that outlier is pulling up that average significantly. It's pulling it up from a 5 all the way up to almost 19. It is drastic. So in future lessons, we're going to talk about how to identify these outliers and how to pull them out of data sets so that we actually have measures of center and spread that are accurate. We've got one more thing to talk about, and that is the median. You guys have probably heard this term before. The median is the middle data point. It is the second common measure of center. So mean is the first most common, median is the second most common measure of center. So what we're going to do is we're going to find the measure of center. What you're going to do if you have to find a median is it has to be in order. So your data must be in either ascending or descending order. In order to find that median. So let's take a look again at my basketball players here. So you can see my basketball players, the data looks to be in descending order, starting with Russell Westbrook with the highest and Wesley Johnson at the lowest. So I want to see what that median is going to be. So I need to know the middle. So we already saw there's 18 players here. So I'm going to count to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this should be the exact middle. Notice I've got 9 players above the line and 9 players below the line. So there's not an exact middle number per se. So what you have to do if there's not an exact middle number is you have to calculate the average between these two numbers right here. So when I calculate the average, I'm just adding them up and dividing by 2. And this is fairly easy to see what number is sitting right in the middle, and it's 25.4. That's going to be my median. If we remember my average for this data, let's go back. So you can see how the median is slightly higher than the mean for this data set. Not too much, but slightly higher. So that is it for measures of center and sigma notation. You should be good for the 1.3 problem set now.